Hey guys, welcome back to this series of tutorials of Unity. If you like this video, please subscribe to my channel. I have a Patreon too. No, okay, so from now on I'll be talking about the examples I uploaded. So this is a bit more specific. You can find plenty of introduction to the Unity interface online, probably much better than what I did so far, but from now on I'll be talking about the files I'm sharing with you that are a bit more tuned toward the assignment of creating a control system. I'm checking like the first scene really is just an object hanging out there, and I was just showing how to to endow this sprite, this game object is just an image basically, with some kind of physicality, with a weight, a mass, and the ability to accept forces. That is I'm referring to the rigid body. So the rigid body is a component that is in physics 2D. Keep in mind that physics 2D and physics 3D are in two different worlds. You can have both working at the same time in the same scene, but they will not be part of the same engine. So the physics, if you're working in 2D, you typically, or if you're settling on 3D, you want to work with physics component. If you're working in 2D, you want to use physics 2D components that usually have the 2D suffix attached to it, and that's the same with functions that we will see later. Like if a function add force will be different from add force 2D. If you're working in 2D and if you're affecting a rigid body 2D, you will have to use add force 2D. You cannot mix two things. They are usually very similar. It's just one coordinate is missing, is the three-dimensional coordinate. So adding a rigid body endows my game object with some kind of like weight and mass. It doesn't have to fall down. I can change the gravity scale to 0 and the object will stay afloat. It will not be affected by the gravity. Note that I can change my all my components dynamically, so I can just like try how things work. And this is super important for physics. So physics can produce very complex, unpredictable relationship between objects, because the way an object moves is a combination of physics and forces and gravity and drag and frictions and so on. If there are things like springs and mechanisms and so on, like imagine like the QoP character, which is kind of like a physics system and involves a lot of like fine tuning in order to be playable and playable at that difficulty level. It's just all a matter of like going through the rigid bodies and the forces and kind of like fine tune them, and Unity provides an excellent way to do it while you're seeing your game running, as opposed to tweaking a number, hitting play, and then tweaking the number again and hitting play again. So here's my rectangle. Now it has a rigid body. Now we can okay, so like every time you change something in every time you change something in a scene and you try to switch to a scene, we'll ask you to say, like in this case I'm not gonna save the changes, but be aware that obviously you have to save your scene between you switch to the other one. So this is a simple situation with like three physics bodies here. They don't only have rigid bodies, they also have colliders. Colliders is the other important thing that you will probably end up using a lot in games, or at least this kind of action-oriented games. So if you have a sprite renderer, there are two things that make it material. One is the ability to accept forces, and the other one is the ability to respond to other objects. So within physics you have colliders. Colliders can be of different kinds: circle, box, edge, polygon. It doesn't necessarily have to match with your assets. In this case, I have very primitive assets that look like a circle, look like a box, and so probably the most obvious thing will be to associate a circle collider to a circle sprite, but it doesn't have to be that way. Like you can use a circle collider for a character or a box collider for a blob. It doesn't, I mean, it really depends on the characteristic. So when you are when you add a box collider, you will have a new element here. Consider that all the components will be collapsible panels, and you can scroll up or down, but you might want to collapse some elements you're not working on. All the like the box collider will be customizable. You can offset it, so it doesn't have to match perfectly your sprite. By default, when you're adding a box collider, Unity will be sort of like guessing, okay, that's the bounding box, so you probably want a collider that is as big as your thing. But in most cases, the collider is of a different size, of a different sort of position. It might be slightly shifted. You can also have multiple colliders in the same object to make like more like complex ones. You can also edit the collider visually by clicking on Edit Collider and pushing on this handles here. It will be relative to the size, and that's why the size is in from 0 to 1. Like 1 means the size of your sprite. That's because you could potentially take your sprite and stretch it, which is pretty common, and the collider will stretch with the sprite. So this is actually pretty nice, unless in the cases that it's not anymore, and you want for some reason a collider that doesn't stretch, but that's a whole different story. Okay, so colliders, you can temporarily disable colliders as always. You can remove a component. You have to remove components by clicking on this little gear icon and hit remove component. Try to not have components that are not in use or not necessary, because they will still be active. Capsule collider, let me see if there is oh yeah, the polygon collider might be actually pretty interesting, because you can edit the number of points and the paths. So you can have like 11 elements, but it can also be like a triangle perhaps, and then you can edit it by clicking here and yeah, kind of like modifying adapting it to your shape. This is actually super cool. Back in my days, you didn't have anything like this, and colliders like that were pretty hard to implement. Okay, so remove collider. That's about enough for colliders. Here you see that I have an asset that has been tinted. This is about the issue of materials. So materials are not extremely, I think has been tinted. They're not extremely important for, oh yeah, it's part of the sprite render. Materials are not extremely important for 2D, because 2D usually doesn't have lights or lights that bounce around surfaces. And so the materials you're going to use is usually the sprite's default. All the other aspects will probably be things like the color, for example. You can dynamically tint or change a color, which is equivalent to the colorize effect in Photoshop. It's part of the sprite render, just in case you were wondering what this thing was. Yeah, here like you have like two objects falling down, and you can play with by selecting them and manipulating aspects of the rigid bodies. So the rigid body will contain things like the gravity scale, which is a bit counterintuitive, because usually all objects in the world are affected by the same gravity. But here in Unity, since you can, why not? You can have a different gravity for different objects, which is different than simply applying a force. So I just changed the gravity to negative, so my object kind of started floating like if it was affected by some kind of buoyancy, and now I change the gravity back to 1, so it will probably fall back at some point. Here it is. Linear drag and angular drag, that's the friction. So the linear drag will affect the way it kind of decelerates in absence of all forces. So it's kind of like the force that opposes every movement, or the angular drag will be the force that opposes the rotation movement, and the mass will be in combination with gravity, will affect the speed of the gravity response, but also the way objects kind of like bounce against each other. Like an extremely massive object will will, if an extremely massive object hits a very like lightweight object, it will probably like send it to stratospheres and so on. Simulated use auto mass, that's not super important. Let's move to the example number 3. Okay, in this case you have the same 3 objects. You have a triangular collider that was added in the same way. It's a polygon collider with 3 interesting, with 6 elements for some reason. Oh yeah, I guess, well, whatever. Yeah, it can be probably summarized in 3 elements and edited manually and so on. You have another object with a rectangular collider and another object with a circular collider, and here you have another kind of collider, which is the edge collider, which is basically just a line. The edge collider is good for situations like this, in which you have a landscape and you don't necessarily need a whole polygon to go around here. Yeah, it's just a kind of like an optimization type of situation. So colliders can also just be triggered, and you will see it in when we are actually manipulating or like detecting collisions via code. So if a collider is a trigger, the object will go through it, like we'll ignore the response, the bouncing of like the physical bouncing, but it will still be triggering an event that you can capture. So you can have, for example, an area of your scenario, your level, that might trigger, for example, like a narrative text or like an enemy spawns only if you hit a certain space, but that trigger is invisible and it's not meant to be a thing you bounce against. So like that's the significance of the trigger. There is a kind of material that is super important for 3D applications that will determine how light bounces on your objects, on your 3-dimensional objects. But there's also another kind of material that is the physics material. So you see when you're running this example, you have like the pink circle that is kind of like very bouncy. There is nothing like bounciness in the rigid body 2D. It's actually a property of the material. I thought it was a property of, oh yeah, it should be a property of the material. Well, maybe it's just here, rubber. Let's see what happens if I add a rubber material to the circle. Yeah, it's about the same. Well, anyway, there is a series of material. Oh, the bounciness here. Let's increase the bounciness to 10 and see what happens. Alright, that was a little bit too extreme. Let's do like 3. Okay, there are a couple of properties that for some reason are externalized in physical materials. So the materials that is designated by this icon, this bouncy ball icon, because it's really just kind of about the bounciness, can be created from the asset folder. It's not an external asset, it's kind of like an internal asset. And it should be somewhere like physics material 2D. So you create that, you can call it, like I call the first one rubber, just because it has this kind of friction, this kind of bounciness. And yeah, that will be, you will be able to associate this material to any possible rigid body. So you can use a different kind of bounciness or a different kind of friction that is specific of that material. That's particularly useful if you want to have different responses that are determined by similar rigid bodies. Anyway, so now the ball is like super bouncy, extremely bouncy, and you can get rid of it by having like, well, if the material is known, it will be basically the default bounciness and the default friction. Yeah, that's pretty much it. Let's go to the 4th example. Oh yeah, in the 4th example, I introduced some elements of code, I thought. Let me see. Actually, it might be like the 5th. Oh yeah, okay. Movement 1, I think I have to add that relative collision forces, maybe. All right, well, let's just switch back to the number 5. This controlling objects. So we already like jump into controlling object using the keyboard, the arrow keys. So here, if you run the example, you will see 3 distinct behavior. I'm controlling them using the WASD, the WASD keys, and the directional keys. Actually, not all of the objects are kind of rotating, but this is a good introduction to adding scripts and behaviors to your objects. So if you're clicking on either of the object, you will see that they have a side of rigid bodies and box colliders. They'll have a script attached to it. So a script can be opened and modified through an external program that is usually by default is mono-developed. I find it okay. Has some issues, has some kinks. Some people really hate mono-developed and tend to use their own, maybe like Visual Basic or whatever other code editor. I think it's pretty good. It's just a bit annoying with the indentation sometimes, and sometimes it crashes or loses synchronization. But basically, if you're double-clicking on a script, it will open an external program here, and will open a representation of your project here, part one mess. Well, this project, I don't know why it's even close it. Okay. A representation of your project that includes only the code aspects of it. So this is, I think, mono-develop is it's an open source code editor. It doesn't have a compiler, it's just a code editor, but it is a different kind of program, so you will have to switch back and forth. Unity is not completely integrated. When you're clicking on code, you can see in the inspector a representation, kind of like a preview of what the code is, but you cannot modify from there. You can modify some expose variables like speed in this case, and I will get into that in a second, but you cannot change code from Unity. You will have to switch back and forth between mono-develop or whatever you're using and Unity. So at its basic level, let's just add a new component that is a new script. You can create a script from scratch from Unity, and that's how I usually do it. Let's say like test script. Actually, I'm gonna maybe attach, let's see. Sure, test script. So new add component, new script. Make sure that you select the C# language, not the the JavaScript, which is not even JavaScript, but it's a version of JavaScript that is Unity specific. And it's being phased out, so do not start learning Unity script because it's gonna be obsolete very soon. So I'm gonna call it test script. In C#, the name script, but the name of a class has to be without spaces. Like the name of a script will be the name of the class, and it has to be without spaces or weird characters. So typically it's capitalized. The convention is to have the uppercase. So test script, I'm using the Camelback convention. Make sure that it's C#, and then create and add. That will create a script here that is called test script, and it should open it. Usually it opens it automatically in mono-develop. This is the basic skeleton of a class, of a script. So you have imports, like kind of fairly standard imports, so there are libraries and so on. There are some libraries that are not imported, so if you let me see, it's like, for example, system UI, or actually maybe like Unity Engine, like for example UI is a very common library that is not imported by default, but if you're doing something with buttons and things like that, you will have to import it, otherwise it will not recognize certain functions and certain commands. If you work with processing and P5 before, you will find a fairly similar situation. You have a start function, first like the public class, yeah, that should be the basic structure. Test script should be the same name of your assets. If you're changing the name here, you will get an error almost immediately, because that has to be, let me see if it produces an error. It has to be the same, exactly the same name. So if I try to attach a test script to something, yeah, for example, it will produce that problem. Let's see if I can just add the script to, like, you see there are many ways to add a script to your objects. One is by kind of like dragging and dropping it to the hierarchy. The other one is to dragging and dropping in the inspector, which is probably the best way, or by adding it from the control panel. So you can add script, and this is the list of your script here. There is a more riskier way, that is to just drag and drop it on the stage. But when you have a stack of objects and game objects all in the same kind of plane, you might end up just dragging something on an object that on a different object that you have in mind. So try to not do that. It's not a great practice. Also, the script can be stacked and accumulated. So in this case, I have two different scripts that are working independently. You can have more scripts of the same of the same kind. It's very likely that if you're like the effect will be cumulative. So if you have a script that pushes, that adds a force to this rigid body, and you have multiple instances of the same script, they will work at the same time and produce like a force that is probably like twice as much as you want it to be. Anyway, text strip, make sure that the class name corresponds to the file name, because otherwise it will miss the references. So mono behavior here, all scripts in Unity by default expand the mono behavior, which is the base class for all the scripts. Mono behavior allows you to access things like game objects, which is the reference to the actual game object that is attached to. So you can make a script that adds a force to the game object, like or to like, well, sure, add component or like get component and so on. But the game object is a reference to whatever object the script is attached to, and it has to be an extension of mono behavior, like a type of mono behavior. So you have a start function and an update function. The start function will happen once when the object is loaded. There is also a fairly similar awake function, so void awake function, that happens in a slightly different contingency. One of them happens before the other. I'm not gonna go into that as well, but you might see a fixed update, which is a slight variation of the update. But the basic idea is that the void start function happens in the beginning of your game, or when the object is created, while the update function happens continuously, typically 60 frames per second or whatever the frame rate is. So here you have the logic of your game, or of the behavior of your object. Here you normally have the initialization, and up here outside of the functions you typically have the global and local variables. So let me open, for example, an 8 direction force. This is a little, yeah, sure, it's not too complicated. So here the 8 direction force just adds a force based on the input. You see that I have two variables here that are kind of global variables, so they will be visible from both the start function and the fixed update function. One of the variables can be public and private. The publicness or privateness will determine whether or not you see them on the inspector. So this is the inspector. 8 direction force is the script that I'm editing now. You will see that I have a speed value here. The speed is in the inspector and it's visible. That means that it can be dynamically changed while the game is running. So it can be like 10, and the the force, basically the speed of my green rectangle will be reduced. If I increase it like 1,000 or 100, the speed will be much faster, kind of like the acceleration will be much faster. That's not a very good name for a variable, but yeah, and so on. So what you scope as public and private will actually be quite important for testing purposes. If this variable was private, it will be still used, visible everywhere in the same code, but it will not be visible by the editor. So as you can see here, well, you will see in a second, yeah, it refreshed and the 8 direction force speed variable is not there anymore, meaning that the variable is still working the same way, it's just not visible from the editor. Other super important thing that confuses people a lot, here, if you're initializing a variable, say speed at 100, and you're changing a variable from the editor here when you're not in play mode, so now the speed in the editor is 1,000, this setting here in the editor will override the initialization in the code. So when I hit play, my rectangle will move at 1,000 unit speed. So this is super important because this 100 here that you see here and seems obvious will not have any effect. I can change it here, I can change the speed to 1 and it will still move at 1,000. You will find this problem over and over. I will explain this problem over and over. It's not actually a problem. It's one of the main, the greatest capability of Unity, because now I have a newly calibrated speed and I don't have to change the code. I can just like tweak it here and go back and forth in the visual interface, and I can save it, and I can have, perhaps more importantly, I can have two version of the same rectangle that have like different properties in terms of speed. So here I'm moving this object here, and I can have two rectangles with the same scripts attached, so they are responding to the same input. One will be responding to a speed of 1, so it barely moves, and the other one responds to a speed of 1,000, and that's because I can override this initialization here. If you want to strongly initialize by code, you will have to put your initialization here. So in that way, both rectangles will have a speed of 100 because the start function will happen. So you see that they move at about the same in the same way. So this initialization here will override whatever is on the inspector. So this is super important, like this happens first and then the inspector takes over, and then the starts happens after the initialization in the inspector. It will be confusing at the beginning, but it's great when you know what you're doing, what happens. The other variable I have here is actually a reference to a component, and that's a very common practice and very important aspect of Unity. So since version, I think version 4 of Unity, you cannot access components directly. You have to access them by using a very idiosyncratic formula that is getComponent. So if you want to apply a force to a rigid body, you have to first get the component that this force is applied to, in this case, the rigid body 2D. So this is how I usually do it. I know that my rigid body is going to be affected by many forces, many potential forces, forces that goes up, the forces that goes down, based on the 4 directions. So I'm gonna save my rigid body in a variable, in a global variable called RB that is just basically a short for this formula. I could potentially access the component rigid body every time I need to apply a force by kind of like copying and pasting it here and typing every time, or I get the component rigid body and then add a force. But it's much easier to just have a shortcut that is basically a reference to that rigid body. So I do this get component rigid body. I create, if I have to access to collider, I can create a collider 2D variable. It should be global, obviously, but I can access the get component collider 2D. I don't know what kind of collider was it, like collider 2D and so on. And so I have a reference to that collider. So now I can reference the rigid body, and I can change, for example, I can change all the variables that you can see here. In this case, for some reason, I didn't want to rely entirely on the inspector, so I'm applying changes in the start function. So the gravity scale will become 0, even if in the inspector is different, it will just become 0. That's because it happens in the initialization. Then I have a fixed update. If you're using physics, you might want to use the fixed update because it's called at every frame but at fixed intervals. So you will not have to necessarily adjust all of your forces by the time elapsed. A bit complicated, but for now, do not worry too much about it. So how do you add a force? We can add a force independently of the input for now. Like, let's just add a force like this. So I'm referencing the rigid body. I access the component by get component, weird parentheses, rigid body, and bizarre open and close parentheses. And now this function looks for a component called rigid body and saves it in this variable called RB. The variable RB obviously has to be consistent with the type of component. So the type of the variable has to be the same. C#, if you used JavaScript before, JavaScript is everything is a var, and you can just save a var in whatever object. C# is a strongly typed language, meaning that all the variables will have to be defined as float, integers, and so on. It's super important because a lot of your bugs and error messages at the very beginning will probably be related to the fact that you are trying to implicitly convert a float into an integer or a rigid body 2D into a collider and things like that. So it will take a while to get familiar, but consider that every component that you can attach on the editor will have a corresponding type, like rigid body 2D, represented in code and represented in the engine, so you can access it. So everything you do through the inspector can be done through code dynamically, except very, very, very few exceptions. So here in my fixed update, I'm adding a force. This force is a vector, is a two-dimensional vector. Let's see if it works. So, well, that was a little bit too much. Let's add maybe like a 1 force. So as soon as I start, the object will, all the objects that have the script attached will have a constant force of 1 unit. They also respond to the other elements of the script, by the way. So I'm adding a force. The force, it's is it force 2D the same? Yeah, no. Yeah, adding a force. The force, since it's a rigid body 2D, is expected to be a two-dimensional force, meaning that the force will have to be expressed in the two dominant components, like the orthogonal components. So the force in a two-dimensional space will always be on the horizontal axis and the vertical axis. So if I apply a force that has only an x component, it will just produces a force that moves the object right. If I produce a force that is positive, like based on the positive only on the vertical axis, so on the second component of my vector, it will produce a force that kind of like moves the object upwards. So the new vector is a bit of a compressed formula. I can also just create more clearly a vector that will be my force. I'm going to call it F, and I construct a new vector. That's how you create a new vector. Vectors are used to define both positions in a two-dimensional space, like X and Y position, but also forces. So the F here will be a composite, so the F will have an Fx component and a Y component that I can access. For example, I can print here, and that's printf x, which is a property of the same object. So super simple object that has basically just x and y, and first parameter x, second parameter y. Here in my example here, I'm getting the input, and I'll talk a little bit about now, and then I'm adding 4 different type of forces depending on the input. The forces can be vertical, positive, horizontal, negative, and so on, that correspond to the different directions I want to go. So it's either like minus speed, 0, and yeah, kind of just moving orthogonally. Obviously, different buttons can be pressed at the same time, because this is happening continuously as long as the buttons are pressed. So I can have all sort of movements also diagonally, because I'm adding different components. So like, yeah, it's kind of moving in 8 directions actually. Plus, if there is inertia, the movements will move, like the object will move in all sort of ways. Obviously, if you're making a game like Frogger or the old-time Zelda, kind of like a tile-based game, you will have probably to disregard all these rigid bodies. You will probably not need a rigid body, meaning that if you're moving programmatically in steps, for example, or you're moving like, just like right, up, like that, you will probably just have to change the position of your object, and there's no force, no physical components involved. Even for things that are relatively physics based, like a platformer game, you might realize that adding forces is not what works for you, and you might even have to just program your own physics simulation, your own jump programmatically, basically, like without attempting to add forces, because forces are kind of complicated. Like it might be, you might not need an accurate, physically accurate simulation of forces and bodies and frictions if you have a kind of like a fantasy situation like Super Mario. Mario doesn't move according to the laws of physics. They are rules that are somewhat inspired by the laws of physics. So you might even want to bypass all the rigid body stuff and move stuff like basically by moving their coordinates. It's much more challenging, but it might be necessary or worth. Here you see an input condition, an if condition that detects the key. So you can there are so many ways to detect keys, but there are a couple of ways to detect keys. Mainly, you want to detect the state of a key, so whether the key in this moment at every frame is pressed, or you might want to detect if the key has been pressed, like in the moment that has been pressed. So either like in a continuous kind of basis, the key is down right now, or the key has been pressed in the last fixed update, in the last cycle, or the key has been pressed now, and so it will be a function that detects that. I have examples that are more about inputs later, but for now, just you can just like extrapolate this, like, okay, get the key. If the key is right arrow, which is key code, right arrow is just like a container with all the most common inputs. So input is an object that is the input manager, the default input manager for Unity. Oh, right arrow. The default. So all the input that you want to read are usually included in input. As you can see, MonoDevelop has a pretty sophisticated autocomplete that sometimes is a bit of a pain in the ass, but in most of the cases will be great. I mean, will be extremely helpful, because it doesn't require you to keep going to the reference. It's basically an integrated reference for all the functions and all the things you can see. So input, oh look, I didn't know that input has mouse position. What is that? And then you have a little explanation here in natural language, current mouse position in pixel coordinates, so you can click in mouse position. But then after that, you might want to, to press the dot again and access all the properties and the and the functions and the methods of that particular object. So input is an object, mouse position is also an object, and the mouse position has other things, like for example like a function to normalize this, whatever that means, or like square magnitude. Never used it, but still it's quite important. I didn't even know that there was you can format your mouse position into string. Most commonly use the mouse as in, okay, read the mouse position on the X coordinate and so on. But yeah, the autocomplete and the integrated reference is extremely important. If something autocompletes in a way that feels weird, like if you have, if you want to access, like, I don't know, like if you're trying to access a variable called collider, and you see that it kind of like Unity tries to autocomplete to, for example, like collider with the capitalized C, and you're like, damn, autocomplete, I just want the variable called COLL, not the collider. If Unity tries to do that, it's usually because it has some good reason to. In this case, the variable call has not been defined yet, and so Unity will try to correct you and say, oh, maybe you are talking about the collider with the capitalized C, which is the type, the class of a collider. So you might have to, for example, create a collider variable called COLL, and then the autocomplete will not fight against you. So call now is part of the language, is part of the variables that are here in the world, in the script particularly, and so you can use it properly. So if the Unity monodevelop autocorrect appears to be weird or annoying, it's probably because you're not using its own convention, its conventions essentially. So you first declare a variable, and then the variable exists, and then you access that variable. Okay, so this is probably enough for the input, and I'm going to talk about the other scenes, but just be aware that there are many ways to move objects and many types of forces. For example, the add force can be a force can be added through an impulse, which is a more instantaneous way to add a force that you might need to use. I think the classic example is, oh, there's an explosion, so the force happens instantly, as opposed to a kind of like an acceleration. Like my example is almost like you have some jets, like some kind of like rockets attached to your square that kind of like propel this object back and forth. And you see this object adding a force is adding a force to the current momentum, to the current velocity. So it will not change the force. You can also change the force, you can change the velocity, and you can access the velocity instantly if you want to instantly change the force and override all the forces and the velocities that were currently applied to the physical body. But it's a kind of like a different principle. Here you're constantly adding a force, and it's more similar to what happens in nature. If you're braking, you're adding a force, or like kind of like subtracting a force, but you're not like reducing the speed itself. You're just adding a kind of like a friction and so on. Anyway, this is enough for now. I'm gonna cover the other example in the next video. All right, bye.